So now let's compare this multigrid. So let's set this to 0 and x equal to multigrid of this. What happens? The assignment has more non-singleton. So something might happen when the size is actually equal to 3. So let me try this. Okay, now that works. All right. So I think when the dimension is 1 in one of them, there is some strange thing going on. So okay. So when I have one iteration of this, let's actually show it. Where do we want to show it? Let's actually show it again over here. Okay. So subplot 3, show it. Okay, so here is just one iteration of multigrid. It's already a lot better, right, than what we have previously done. And let's just do a few iterations and show it again. Still suspect that there is a bug in the code somewhere. But it seems this bright dot is there after even many iterations. Do you guys see a problem somewhere? Laplaceing.
So what happens if there's no multigrid for the C, then you just set it to 0, right?
Yeah, if there is no multigrid for EC, I just set it to 0. So basically, there is no correction over here, right? Which should be fine. Right. Okay. So 10 Jacobi iterations, passing. And could there be a discrepancy in our Laplacian and Jacobi? So Laplacian or Jacobi iteration. Relation to a fine grid. Okay. So this is this actually so in a proper implementation, after a few iterations, this should actually have already converged to the true solution. I think just somewhere over here might have a problem. For example, if I multiply this by 0.5, basically discounting the this actually helps at all. Wait, did I actually, is it actually updated? Okay, another thing that might help is in some multigrid implementations, there could be also something called a post-smoothing. So this is basically apply a few Jacobi iterations after the interpolation. So let's see if that helps. Still no, huh? So I don't understand what makes this blob appearing here. Okay. if I apply Laplacian of x minus bc, actually get so I'm inspecting my residual here, which is which seems to have a checkerboard pattern over here. So I might suspect that things are wrong during the interpolation because of the checkerboard pattern I see. Okay, so let's actually look at the interpolation from cos to fine again. 2 to 2 to end is gonna be 1 to end minus 2, 3 to end. This looks fine, and 1 to end minus 2.
For the interpolation, you're changing, the grid gets coarser and coarser, but the interpolation is always at the first refinement level. Like so interpolating the 0 values. Because your step size E when you do the interpolation is 2, but actually it should be like 4, 8 and so forth, right? Because you're always cutting down when you do multigrid, no?
So in every function call, I'm only interpolating between two adjacent grids, right? So I'm never actually directly interpolating in between grids that are more than one factor of a refinement. Okay, so let me actually figure out what's wrong in this code, and maybe I'll post it on Stellar.
So like, you show that the residual had a checkboard pattern.
Yeah.
So like interpolating, like taking 1 point, 1 point, 1 point, you might just take all the like whites from the checkboard or all the blacks from the checkboard.
Yeah. Can you say again?
So like the residual is like checkboard pattern. So
right.
The interpolation from find the course is taking point, 1 point, and it's keep on point, another point, 1 point. Might take all those like white in the checkboard or the black in the checkboard.
I'm looking at the I was looking at the residual here, right, to see the checkerboard pattern. I mean the interpolation is actually on the solution area, not on the residual. The residual is interpolated from fine to coarse over here.
Yeah, so fine to coarse, it might do some data because the residual is checkboard.
Right. So say maybe if I increase this to like 20, that'll help. No, it's the same. So I'll figure out and post on Stellar what's wrong with the code. All right. Okay, thanks.